This video will talk about Unit 6, Introduction to Quadratic Functions, Day 32, Changing the Vertex. How does changing the constants in the vertex form of the quadratic equation impact the graphs? And we are going to focus on reviewing the launch from this video. So if you have not done the launch yet, you can take a moment to go ahead and describe this graph and just pause the video. But if you have, we're going to jump right into going over it. So the launch asked, describe the graph representing y equals x squared. Include as much detail as possible, including all important points. Okay, so I'm just going to go to Desmos. I'm going to use this as a template, and we're just going to graph it together. So when I see y equals x squared, the first thing that I'm looking for is what is the vertex? And we know from vertex form of an equation, what we've been learning earlier, that the vertex is found in the equation when it's written in vertex form, h comma k. Well, in this situation, we don't have an h and we don't have a k, so we know they're 0. So the vertex is really 0, 0. So we can go ahead and start by plotting that point, 0, 0. The next thing we know is we know the axis of symmetry goes through the x-coordinate of the vertex. So we know the axis of symmetry here is just 0. So I can draw an axis of symmetry right on my y-axis. Oops. Okay. We also know that in this situation, the vertex 0, 0 is also our x-intercept or our 0, because that is where the graph we know is either going to open up or open down, and that's the only point at which it's going to cross the x-axis. Because we know this is a parabola, because we know it's a quadratic function, because it has a squared term, and it doesn't have any other terms with an exponent greater than 2. Now we have to ask ourselves, does the graph open up or down? Well, if we look at the equation, we see y equals, this is really like y equals 1x squared, and 1 is a positive number, so we know that a equals 1, and we know the graph is going to open upwards. So now the next step is we need to figure out, so we know our graph's going to go this way, we need to figure out a couple of points to plot so we can actually create this graph. So in order to do that, I'm going to make a table. Oops. Okay, let's actually use a different color. And we'll just call this x and this y. And we're just going to make a table that matches this equation. We know it's opening up. I'm going to choose some points over here, and I'm going to choose some points over here so I can start to see the symmetry, because we know quadratic equations are symmetrical. So -2, -1, 0, 1, and 2. Just need a couple of points on each side to be able to graph it. Well, we know that at 0 already, it's 0, 0. So let's do -2. -2 squared, right? Y equals x squared. So -2 squared is 4. -1 squared is 1. 1 squared is 1. 2 squared is 4. So we already see that symmetry happening, and we see that 0, 0 is a minimum in this situation. So now I'm going to go ahead and I'm going to plot those points. -2, 1, 2, 3, 4. And I'm going to do it on the other side too. I'm going to just get that symmetry started. 2, 4. And then we have -1, 1. And we have 1, 1. And you should see it starting to make a U shape, and you should see the symmetry. And now that we have that plotted, we can go ahead and sketch out. And this is not a perfectly sketch because the computer is tricky, but this is okay for a rough sketch. Oops, let me fix that one. A rough sketch of our parabola, and we want to put the arrows on the end to show that it's increasing, continuing to go up in both directions. Let's see what the actual, so now I'm going to actually graph it on Desmos. This is how you would graph a parabola by hand. Just needing to find those key features and then also plot a couple points using a table. I can also go ahead and graph it on Desmos. And you're going to see that it closely mirrors the one I created. As you can see, I went too far out a little bit. I should have stayed inwards, but it's okay when it's a sketch to be a little bit off as long as you have the general shape of the beginning. If you wanted to, you could do -3 and 3 to get a little more accuracy when creating your graph. So in summary, in order to graph a parabola on a coordinate plane, you simply need to identify the vertex, identify a couple of points, identify what direction the parabola is, if it's upward or downward, and then also just ensure that you have symmetry on both sides, and you should be able to create that graph by hand without using a graphing calculator. Still, a graphing calculator is a great tool to check your work and verify that what you did was accurate and there were no mistakes made.